Hi. Good morning to distinguished guests of the dais and my respected friends. Today, I have got a very interesting topic to deliver. This is a recent development which is presently going on in Mumbai, the Trans-Harbour link connectivity. And in this, we are associated, AECOM is associated as the general consultant from the authority side. So to start with, just I will give a brief about our organization, which most of us already know, but AECOM was founded in 1990. It is one of the Fortune 500 international consultant. It is the largest infrastructure consultant in the world, and we have got offices over 150 countries around the globe. So we are number one in most of the disciplines that we work in, and we have got a strength over 87,000 around the globe working for this with a revenue of $20 billion. So today's content, we will be covering advantages in steel bridge construction. I will be featuring the project Mumbai Trans-Harbour Link. Also, we will be looking into various aspects of the project, and we'll also look or glance into some of other projects that we are involving in steel in India, and also some global steel projects. So what are the advantages of steel construction? The first one is that we can deliver a slender section if we are using steel, which generally results in lesser material consumption, and then we get lesser carbon footprint. So it is more favorable also in the high seismic zone due to its ductility and lesser weight. So the construction's time, if we use for a prefabrication concept, the construction's time can also be reduced in most of the scenarios. Further, due to its controlled manufacturing environment, it gives more good material, so the uncertainty in design is also reduced. And it is a good material for easier reuse and recycle, so that gives us a better sustainable material as well. So just to give you a project overview on the MTHL project, this has got three packages or three phases, package 1, 2, and 3. Which covers a length of about 22 kilometers, and it is planned to have a construction period of 4 years. In this project, the steel was extensively proposed and being used in most of the superstructure part. So we'll come to the details. So this is basically the packages where we have got various spans, which is maximum of 180 meters steel span. So in the initial phase, we had an option study to consider various options. So the first option was the continuous four-span PSC box girder bridge. Second one was the continuous four-span steel box girder bridge. And the third one was continuous four-span extradose bridge. Out of this, we evaluated a long-term aspect, the total life cycle cost, and it was came that the steel option is the best preferred one. This judgment was, or the consideration was based upon few considerations, such as durability, seismic resistance, quality control, construction period, environmental impact, and construction cost. Now I'll come to the package 1 of this, which is presently being constructed by L&T IHI joint venture. So in this package 1, we have got various spans. This might not be much visible because it is a little bit small, but then this package consists of mainly 4 parts, which have the maximum span of 180 meters. This is a steel construction for the superstructure. So these have got these 4 locations. Now the superstructure details are a steel box superstructure, as I was mentioned, and these have dual carriageway, each carrying 3 lanes. The utility ducts has been planned that this will be through the boxes and not from the outside. So this is the typical cross-section of the proposed thing which is being constructed now. So salient features of the steel boxes, which includes steel box girders with orthotropic deck plate, constant width of the box, depth of the box varies from around 3 meters to 6.6 meters within the integral piers. And then steel grades has been used generally about SM 570 and 490Y, which is generally the Japanese steel. So again, these are the basic dimensions that we have here. This is a typical cross section, just to give you a detail that the deck plate is around 16 mil, and we have got orthotropic steel deck, which is around 600 in between the spacing. The erection scheme for the main bridge was basically defined with a concept that the sections will be fabricated in the yard, then it will be transported through garden segments to the through multi-wheeled trailer barge, and then these will be considered as a large block, and these will be finally lifted through to the position by a barge and on a floating crane. So something like this will be happening. So the barge will be bringing the block to the nearest location, and then it will be lifted to the position through a floating crane. Some of the site photographs that we have regarding the construction, which is currently ongoing in this package. Now coming to other projects, which is also steel construction in various parts of India that we are presently doing. One of these are the iconic cable stayed bridge in Amaravati. This is also having 180-meter spans in the cable stayed portion. This is a steel deck which is being planned. Second one, we are also doing few NF railway bridges which have got steel superstructures, truss superstructures. These are for the Northeast Frontier Railways, is being constructed. This is a bridge over two rivers, the Barak and the Mokru in Manipur. So these are also having steel superstructure. So what we can see that steel being used as the most preferred option in most of the projects. And some of the featured international projects that I will also like to highlight here. One of them are the Padda Multipurpose Bridge, which is one of the strategic connectivity in Bangladesh. This is having a maximum span of 150 meters, and it is a dual deck. Basically, it's a road and rail bridge, and it is a major connectivity now in Bangladesh. The second one is the Shutong Bridge. This is in China. So this is also having a steel deck. So this is also a major connectivity is in China. This is one of the bridges in US, the Tapanzi Bridge. This is also a steel superstructure. And this is a bridge for part of the highway project in Trinidad and Tobago. This is also being constructed as a steel superstructure. So the summary I would conclude as that steel in a present scenario is one of the most preferred element of construction. One of the reasons being is it can be prefabricated and faster in construction. Further, it is a sustainable material, so it can be reused and recycled. So with these words, I would like to conclude my session. Thank you.